Hello, greetings of the day. Myself, Dr. Suresh Chavhan, working as an assistant professor at Vellore Institute of Technology in Vellore campus. Today, my talk is on 5G, which is technical overview. My objectives includes what is 5G and why we need the 5G communications, and I will be talking few use cases of 5G communications and roadmap to 5G and 6G. So from the 1G 2G, so what and all changes has happened, right, to come to 5G, and what are the changes need to happen, or why the changes need to be done in 5G in order to do the 6G communications. And I will mention 2 to 3 main challenges in telecommunication networks, and I'll be talking about the comparative and the key performance indicators, especially for the 4G, 5G, and 6G communications. And already for more than 5 to 10 test trials has been done on 5G. So main takeaway from today's presentation of mine is a high level understanding of 5G and 5G techniques. So moving on to the next slide, what is 5G, right? So what is the 5G? 5G, it's a wireless connectivity between people and devices, right? So even the 3G and 4G also does the same purpose. So what is the main difference between the 4G or 3G and 5G, right? So you can see in this figure at the right side, so there are many number of devices. You can think of it's one house or one mall, right? So how many devices are there, how many equipments are there? In future we will be talking only about, not we won't be talking, so the device will be talking. So device will assist us in order to provide the necessary services, right? So for that we need a very good communication infrastructures where it can provide to a massive number of devices, right? To massive number of devices need to interact with each other, they have to share, right? So for that we need a very good communication infrastructures in terms of the data, right, in terms of the number of devices, in terms of the delay, in terms of the throughput, and so on, right? So those all things will be provided by the 5G communications. So, how the 5G research has started? So 5G research has started in 2013 or 2014 end, and they have released the 12 in the end of the 2014, and in the 2015 starting they have developed the WRC 15, and in 2016 they have standardized whatever the research they have done so far, right? And once the standardization is done, once the standardization name has come, when the standardization has published, or once the standardization has made to the public, right? So we need to prove that whatever the standardization we have made, right? We say for example, for V2X we need on the standard protocol that we call the IEEE 802.11p, which provides the 5.9 gigahertz of frequency, right? So once we have standardized these things, we need to test that, we need to experiment that, we need to test in the various scenarios, right? So for that, at the very first we need to develop, right? So development and testing is done between the 2017 and 2019 mid. Once this development and testing is done, then they have done some few field trials as well. So those things we will. And now they have made a commercialize. They have made to the public. They are selling to the publics, right? So this is about the 5G. So moving on to the next slide, why we need to study or why we need the 5G, right? So in the earlier slides, I have shown a one right side image and I have explained why we need it, right? So we will see in detail about that. So you can see in this figure, here I have written that ultra fast data transmissions, right? So data transmission one, fast data transmission is another, and ultra fast data transmission means within a second I have to send a 10 Gbps of data, or more than 5 Gbps of data I need to download it from the internet or from the server, right? So you can see the 3G will provide in 1 second, right? 384 kilobytes of data we can download it, or data we can share. And in 4G we can at the max 100 Mbps of data we can download it from the internet or the server. And 5G provides 10 Gbps. Just think, even our hard disk, won't be having this much of space, right? So the another important performance measure uh, of 5G is the ultra low latency, right? So the data we are transmitting, the data we are sharing, the file we are sending from one place to the other place, so that has to be immediate. There should not be any delay involved in it. So we need to optimize the delay here. So the 5G provides the optimized latency solutions. So next one is the ultra high reliability. So whatever the device A wants to send to the device B, right? So that has to be immediate, very fast and low latency, and whatever it has sent the data, that has to reach in the correct order, right? And we have to get a proper acknowledgement there. So the 5G will provide the ultra high reliability and massive connectivity. As I mentioned in the earlier slide, suppose in the mall you will be having a many equipments, right? You can think the trolley, you can think of dresses, each type of dresses, right? And you can think of the assistants, right? And you will be having the cameras, you will be having the fan, AC, right? And huge number of devices. So for all huge number of devices, suppose you don't want to go to each and every device and get the optimized price and very good product for you, right? So all the time it's possible, but sometimes it takes a lot of time. Suppose we develop applications which can make or which can interact with all the massive number of devices and come to a conclusions. So this is what, this is a phrase, this is a device. So these are all the different devices are there with respect to their performance, with respect to the cost. So this is how it looks. So for all these communications we need a 5G. So that's why here I have written the 5G provides a massive connectivity in the environment. And the another one performance parameter is the uniform user experience. So you can see in the metropolitan cities, for example Bangalore, Delhi, Mumbai or Chennai, right? So these, the growth rate in terms of the infrastructure, building infrastructure has grown like anything. So they are all not a uniform, right? One is very high, another is low, medium. So like this infrastructure is there. So at that time, due to this, we will be having the issue of non line of sight, right? So the what 5G does is it will make the uniform user experience, means there should not be any disconnection, or in technically what we can say that there should be always the seamless connectivity from one point to the another point, or one location to the another location of the user. So that kind of service will be provided by the 5G. So moving on to the next slide, that the use cases of 5G. So actually the 5G communication provides the three main services. So the very first one is the enhanced mobile broadband. In short, we will be calling as EMBB. And the second one is the machine machine type communications, that we call MMTC. And the third service provided by the 5G is the ultra reliable and low latency communications. In short, we call the UR LLC. So the very first service that we call the enhanced mobile broadband. So what it does is it has the characteristics of 10 to 20 Gbps for uplink and the downlink. Means if you want to download or you want to upload the data or the file or the any kind of a video, right? So the data rate for the uplink and the downlink is the 10 or 20 Gbps. So uplink it will be 10 Gbps and the downlink it will be the 20 Gbps. So this kind of data rate, right? So for which type of application we need to apply. So here I have mentioned the few applications for the EMBB. So the very first one is the video streaming, right? We are addicted a lot to our mobile, right? Mobile and the internet. So without mobile we cannot go out from the house or from the your place where you are sitting right now. If you want to move from that chair to the another chair, you will hold a mobile in your hand, or keep your mobile in your pocket and you will move, right? So during this, there if you want to see the video streaming, right? So the their uplink and downlink data rate should be more. And file downloading on online games. Now the youngsters are addicted for the online games, right? And virtual reality and augmented reality, thank god it has not come into reality till now. If it comes, I don't know what will be what is going to happen in future, because virtual and the augmented reality, what it makes is, suppose I'm talking to you, right? I'm presenting right now. So at this time, so I'm in the Vellore, Tamil Nadu, and you are in your place, right? So virtually I'll be the way I look, right? The same face, the same body structure will be visible to your eyes, means in front of your eyes, though you no need any screen there. Like in our mobile phone, how we interact through the video, like that the virtual reality, the virtual image of me will be created in front of you or to the screen, right? And the second service is the massive machine type communications. So here the word massive machine type communication, so you have to think that the massive number of devices will be connected. So those kind of services it will provide. For example, here it provides a 10 raised to 6 devices per kilometer square. And the applications it is used for the you can think of the your mall, right? Or any kind of industries where a huge number of devices are there. And the third one is the ultra reliable and low latency communication, URLs. This is the best services, and I like a lot because I'm working on this area, ultra reliable low latency communications, and it provides the 99.99999% reliability, right? So that is like a purest, right? And it has the less than the 1 milliseconds, right? So this kind of a reliability, this kind of a delay. So where we need, in your mind, first it will come the autonomous vehicles and vehicle to everything communication. I work, my research area is completely on the vehicle to everything communications, intelligent transportation system. So, and I work in this area. So moving on to the next slide, that's a roadmap to 5G and 6G. So the how we have reached to 5G and how we are going to reach to the 6G. So in the 1G, there's only the analog communications, and their main technologies was the advanced mobile phone systems AMPS and Nordic mobile telephone was there, right? And there is a huge research on this, and in 1991 they introduced the second generation. So there they have introduced the GSM, that is the global system for mobile communications, right? And digital AMPC, that is a digital advanced mobile phone system. So there they introduced the SMS, digital SMS, right? So we are sending the earlier, before the WhatsApp, before the Facebook, right? We used to just send a SMS through our mobile, right? So those things. And in 3G was introduced in 2000. So there is a huge research on the UMTC, that is Universal Mobile Telecommunication System, and wideband CDMA, and their main introduction was the, so earlier there was just an analog communication, then SMS introduction was there, now the audio was there, and the text we were able to send it. Why can't send the video, right? So that was introduced in the 3G. And in 4G, there is a huge research again on the communications, and they used the long-term evolution LTE and long-term evolution advanced A, right? And here the main purpose is high performance and low cost, which we are using. So we are able to do the video streaming, we can send the MMS, right? So many things we will do, right? So that was introduced in 2010. And right now 2020, 2021, 2022, 2023, maybe 2025 and 6, the 5G complete implementation will be there, right? And their main technology they are using is the NR, that's the new radio waveforms. And maybe after 2010 or 2020 or 2025 and 2020 2030, there's a 6G introductions. And I have read many papers right now, they are already working on the 6G communications. And then there are few challenges in telecommunication network, and here I have mentioned the main three challenges. So the very first one is the capacity crunch problem, and the second one is the multipath noise is a challenge, and we will be having the interference challenge as well. Means suppose you can consider the two cell 1 and cell 2, so their intersection area, so that is the having the very least QoS support, right? And the main problem there is, one is the very low throughput will be there, and very high delay will be there, and the interference also will be there, right? So these are the main challenges need to be addressed in the telecommunications. Right, now we will study the comparative analysis of 4G, 5G and the 6G. So we will study with respect to the key elements. The first element is what are the technologies these communications or the generations are having, 4G, 5G and the 6G. In 4G, it has the OFDM, MIMO, carrier aggregation and heterogeneous network. And in the 5G, NOMA, millimeter wave, dense network, coordinated multi-point cloud computing, and a software defined network, network slicing, edge computing, fog computing, right, and so on. And in 6C, there's addition or the novel addition features are in terms of the technology, artificial intelligence, machine learning, right, and so on. And so 5G, 4G and 6G, the service, what are the service objects? So 4G they focused on only the people, and in the 5G they focused on connecting the people and machine. And in the 6G, interaction between the people and the world, any kind of, even the wall can talk. So like that the complete arrangement will be there in the 6G. And there are huge applications for the 4G. Even you can tell few. So high definition videos, which we are having, HD videos, mobile TV, mobile internet, mobile pay, right, Google Pay, right, phone pay we are having, so those kind of thing. And in 5G, virtual reality, augmented reality technologies, IoT, smart home, smart city, smart factory, autonomous driving, robotic surgery. Though our India government, central government has identified few smart cities, right? Some of the areas they have deployed this communication framework, but not all. So if they deploy everywhere, right, whole city, the communication infrastructure, right, 4G or the 5G, right, 5G is the better, right. So at that time, like, you no need to ask anyone, you will get automatically there whatever the resources or whatever the services you want, right. And the autonomous driving, so one of the booming area, so this I will call the next generation intelligent transportation systems, autonomous vehicles. And robotic surgery, where the robots will come and do the surgery to a patient, right. So what they mean, idea here in the robotic is, whatever the diagnosis procedures are there, so those processes we need to code and dump into the robotic memory, and according to that it will do the surgery. But one point is very clear, so this robotic surgery, they don't have any feelings. And in 6C, so there will be definitely complete autonomous vehicles implementation will be there, and holographic technology will be there, like space travel and deep sea sightseeing, etc. And key performance indicators of these generations are, in terms of peak data rate, so 100 Mbps will be there in the 4G, and 20 Gbps for the 5G, and more than 1 tera bytes per second in the 6G. Just think about 1 terabytes per second. Even our laptop doesn't have that much memory, right? And experienced data rate, so in the 4G it will be 10 Mbps, and in 5G it's 0.1 Gbps, and in 6G 1 Gbps. And the spectrum efficiency in 4G, it's 1 time of 3G, right? Means the resources, the frequency, and in 5G it's a 3 times than the 4G, right? Suppose you are considering the spectrum efficiency here, sorry, in the 4G it's like a 100, right? In the 5G it will be the 300, right? And in the 6C it will be the 300 will be like a 1500 to the, okay, 10 times that of 5G, right? And in terms of the network energy efficiency, in 4G 1 time of 3G, and 10 to 100 times that of 4G in the 5G, and 100 times that of 5G for the 6G. And connectivity density means the number of devices we can connect per kilometer square. So for the 4G it is 10 raised to 5 devices, for 5G it is 10 raised to 6 devices, and for 6G it's 10 raised to 7 devices. And when we think of the latency wise, means the whenever we send the data from A to B, right? So the how much time it will take extra, right? Suppose the data which has to send from A to B, it has to reach to the B at 3 milliseconds, but it is reaching at 4 milliseconds, means the latency here is the 1 millisecond. So like that, for the 4G it's a maximum 10 milliseconds, and 5G it's 1 milliseconds, and for the 6G is 10 to 100 microseconds. And the 5G, they have done the few test trials. So 5G for flying drones. So the company called Ericsson and China Mobile, they successfully demonstrated the concept of the handovers with respect to the flying drones, right? Whether they'll be having the seamless connectivity. So they have created the many heterogeneous networks, and they made the drones to fly from one location of the head net to the another location of the head net. So uh, with this, they have validated whether handover works perfectly with the 5G enabled cellular network. And 5G for high speed connectivity, the company called Ericsson and Korea Telecom, they achieved a throughput of 25.3 Gbps by implementing the millimeter wave technology. So this says that the 5G is used for the high speed connectivity, right? 25.3 Gbps means it's a use, right? Means per second you will get a 25.3 Gbps, 3 gigabytes of data. And the third test trials is for the remote driving reality. So the company is called Telefonica, Ericsson, the Royal Institute of Technology. They showcase the world's first remote driving car during the Mobile World Congress. And the fourth trial is for the virtual reality entertainment system. The company called Tobo Tower Skytree Company Limited and Panasonic Corporation, they exhibited to transmit a live concert to multiple users without any interruptions, right? And which was recorded in 4K high resolution 360 camera. So that proves that 5G is highly used or very good suitable for the virtual reality entertainment systems as well. So with this I am concluding. Thank you. So for further communication you can contact to my email ID, and thank you so much for listening my talk. Thank you.